Hello everyone. In this video we are going to look at exam past papers, but we're going to focus on the chapter of functions. So this video is for the grade 10s. Without any waste of time, we can just go right to it. The first question that we have here is question number 5. And then before you can answer any question, please make sure that you read the statement attentively so that you don't miss any important information. So we are given that a sketched below are the graph of f at x, which is ax squared plus q, and the graph of g of x, which is 1 over 2 all raised to the power of x minus 4. So this graph of f here, it has to be a quadratic function because it has a general equation of a quadratic function. And then also the graph of g here, it has to be an exponential function because it is having the general equation of an exponential function. And then also, if we look at the sketch here, there's an indication to say now the graph of f is this function of a quadratic, which is a concave down. And then the graph of g is this exponential function that is having the asymptote line at this point here. Okay, so remember now, if we have a quadratic function, so remember a quadratic function is given as ax squared plus q. And then we know the value of q here, it will represent the value of the turning point, or what we call the x-intercept of our quadratic function. And then also the value of a will represent the concavity of our graph. And then looking at the graph that we have here, we have a concave down. So that means the value of a must be less than 0. That means it must be a negative value of a. And then remember the graph of what? The graph of exponential function is given as a b to the power of x plus q. So the value of q here, it always represents our asymptote. But if we look at our equation here, we have now our asymptote to be negative 4 because now the value of q is negative 4. So this means now this line whereby the graph is not touching, it is having the value of negative 4 because we take that from what? From the graph of g, which is exponential, and then the value of q represents the asymptote. So also the value of a here, that means the value of a, it will represent if ever our graph is on top of our asymptote or below the asymptote. So the value of a from the graph is positive, so that means it's going to be on top of our asymptote, of which is what is happening on the graph there. And then lastly, the value of b, remember the value of b, if the value of b is in between 0 and 1, that means our graph is going to be a decreasing function. But if the value of b is greater than 1, that means our graph is going to be an increasing function. But on the problem here, the value of b that we have here is going to be half. And then half is what? Is in between 1 and 0. So this means now the value of half is going to be somewhere in between 0 and 1. So this means the graph that we have, it must be a decreasing function. So if we look at the sketch that we have here, if we move from left to right, the graph of g is what? Is decreasing. That is why we say it's a decreasing function. So all this information that we have, we can relate it to the equations and make sure that if everything we have is correct. So now we can just continue to answer or read the statement so that we can be able to answer all the questions. So they say now a and b are the x-intercept of f. So the point of a and the point of b are touching the x-axis and they are the point on the graph of f. And then the graphs intersect at point a. So the graph here, they intersect. So remember now, when you talk about the point of intersection is whereby the two equations or the two functions meet together. So the graph of g and the graph of f, they are meeting at what? At point a. And then also now, E is a point on what? E is a point on the graph of f, and then it's having the coordinate 1 is to 3. They also tell us now C is the turning point of f, and then D is the y-intercept of the graph of g. And then remember, if you want to find the coordinates of the intercept, you always say what? For x-intercept, you let the value of y to be 0, and then for what? For y-intercept, you let the value of x to be 0. So the first question that we have here, they say now write down the coordinates of D. But now if we look at D here, D is actually y-intercept, and then it's lying on the graph of G. So we're going to say now, if we want to find the coordinates of the y-intercept, we're going to say y-int, the value of x is equals to 0, and then we also find which function is this point. This function is on the graph of what? Of G, and then the equation of G is given as g at x equals to 1 over 2 all to the power of x minus 4. So we have to substitute the value of x so that we can get the y-intercept. But now remember, this thing here, g at x, is the same thing as the y. But now we're going to look at the value of y, where the value of x is 0. So if I write it like this, I mean now the value of y, g at 0, that means is the value of y where the value of x is equals to 0. So where I see the value of x, I'm just going to substitute 0. We're going to say we have 1 over 2 all to the power of 0 minus 4. So now if you put everything in your calculator, you will find that the value of g is going to be -3. Please pay attention now. Any number raised to the power of 0 is not going to be 0, but it will always give you 1. So it's going to be 1 minus 4, which will give us what? The value of -3. 1 minus 4 is going to be -3. So this will mean now the coordinates of what? The coordinates of point D are given as the value of x is 0 and the value of y is calculated to be -3. So we find the coordinates of D to be what? To be 0 is to -3. So the question continues to say now, also find the range of the graph of G. So but now remember, when you talk about the range, we talk about the y values of the graph. So if we look at the graph of G, the graph of G is the exponential function here. And then this graph of G, it is above what? Above our asymptote. So this means now the values of y must be above the asymptote. So that means now it's going to be what? Where the values of y are greater than -4, because our asymptote is having the value of -4. Or we can also represent this as what? Y is an element from -4 to positive infinity, because it goes, it continues like that up to infinity, which is positive infinity. So the next question, which is 5.2.1, they say calculate the coordinates of A. So remember now, point A here is an x-intercept. It's an x-intercept, but is a point on what? On the graph of G and the graph of F. So we can use what? Remember, if you're looking for the coordinate of the x-intercept, you always make the value of y to be equals to 0. But now we have a choice. We can use the equation of G or the equation of F, because now this point is lying on both the functions. But if we look at the graph of F here, we don't have a lot of information. So that means we are bound to use the graph of G, because it's the one that is having more information. So we'll say now the graph of G of x is equals to what? 1 over 2 all to the power of x minus 4. But because we are looking for the x-intercept, we're going to make the value of y to be 0. So remember, this g of x is the same thing as 0, as y, I mean. So we're going to substitute it as 0. And then we're going to look for the value of x. So now, for us to look for the value of x, we have to take this 4 and transpose this to the other side. So this is going to be what? It's going to, when it comes to this side, it's going to be positive 4. And then we have 1 over 2 all to the power of x. So if we look at this, we can write 4 as a base of 2, and then we can also change this to be at the base of 2. So 4 as a base of 2 is going to be 2 to the power of 2. And then this half here, it can be written as what? 2 to the power of -1 all to the power of x. And then now, if we want to solve for the value of x, we will say now we have 2 to the power of 2. And then -1 will multiply with x, which will have 2 to the power of -x. And if we equate the same basis, that means we drop the basis and we equate the exponent. So we're going to have 2 equals to -x. And then we divide both sides by what? By -1. We therefore find the value of x is equals to -2. So now the coordinates of A is going to have what? Remember, the value of x is -2, but this is an x-intercept. That means the value of y is going to be 0. So we find that the coordinates of A here is going to be negative 2:0. Okay, so remember now A is also the x-intercept of what? Of the graph of f. So if that is the case, if we have what? The value of A as negative 2 for a quadratic function, that means the other intercept here, it will have to be what? It will have to be positive 2:0 because that is a quadratic function. Okay, so we can already write that for ourselves. So the next question says that calculate the values of A and Q. So, but now if we look at what we have here, A and Q's are on the function of what? Of the quadratic function, which is f at x equals to a x squared plus q. So remember, if we want to determine the equation of a graph, we actually need to do what? We need to have 2 points, at least 2 points, okay? So now we can see now we have this point of E here that is given to us, and then we also have calculated the point of what? The point of A there. So we can use those 2 points to do what? To find the equation of our quadratic function. It was going to be much easier if we had the coordinates of C, because you know the coordinates of C is going to be the same as the value of Q, because that is the turning point. But it does not make any difference even if we have another point, not C, but another point on the graph. Okay, so what is happening is that we're going to take 1 point, for example, the coordinates of A, which is equals to negative 2:0. We are going to substitute them on our equation, and then we say now that is going to be the equation number 1. And then we're also going to take now the coordinates of E and then substitute them on the equation, and then say that is equation number 2, and then we solve for simultaneous. So let's put this on the equation. Remember now, our equation is this one here, f at x equals to ax squared plus q. So we know now the value of y is going to be 0. So we're going to say what? F at x is 0, and then we have a, the value of x is negative 2 all squared plus q. So we just take all this, substitute them on what? On the equation there. So that means our first equation that we get is going to be 0 equals to negative 2 squared is just going to give us 4a plus q there. So this is going to be our equation 1. So the equation 2, that means you're going to take what? The other coordinates. But now, be careful now. You can't take both the x-intercept of a quadratic function. You need either x-intercept and the other point, okay? So now we can take what? The point of E here. So the point of E, it is having the coordinates to be what? To be 1:3. So that means now on our function of f, which is f equals to a x squared plus q, where we see x, we're going to put 1, and where we see y, we're going to put 3. So remember, f at x, it represents the y, so we're going to put 3 here, and then we have a, and then this is 1 squared plus q. So if we simplify everything, we're going to say now 3 equals to what? A, because 1 squared is going to be 1, and then we have plus q here. So this will be equation number 2. So if we look at equation number 1 here and equation number 2, we can actually use an elimination method. But remember now, if you solve for simultaneous, you are not bound to use elimination method. You can also use a substitution method. But in this case, for myself, I can see now it's going to be much easier if I use the elimination method. So when you use the elimination method, you write down your equation next to each other, and then you either subtract or add so that you can do what? You can cancel one of the variables. So now what I'm going to do is that I'm going to take equation 1 and then write it here next to my equation 2. So that means we're going to have what? 0 equals to 4a plus q. So this is my equation 1. So now if I'm looking at this 2 equation of mine, I'm saying now, actually, which variable I can get rid of? I can see now I can get rid of the q here, because now if I say the equation at the top minus the equation at the bottom, that means q will cancel out with q, and then it's going to disappear. So let's do that. We're going to say now 3 minus 0, then we're going to have 3 here. And then we say a minus 4a, this is going to give us negative 3a. Okay, but now if you say q minus q, that will cancel out, and then we have got rid of one of the variables, then we can solve for the value of a. So if we solve for the value of a here, that means we must divide both sides by negative 3, and then we find that the value of a is going to give us negative 1. And then remember, we already knew that, okay, the value of a, it must be negative because we are having a concave down. So you see now, our statement was correct. So now, if we want to find the value of q, you can either substitute it on one of the equations that we have here. Remember, we have equation 1 and equation 2. So you can just choose the equation 1 or the equation 2, and then you substitute the value of A as -1, and then you get the value of Q. So we can choose the equation number 2 there. Remember, equation number 2, it was 3 equals to A plus Q. So this will mean now, where we see what? Where we see A, we can just put -1. So this is going to be a -1 here. We have plus Q. So when we transpose the -1 to the other side, we're going to have 3 plus 1, which is equals to Q. And therefore, the value of Q will be what? 3 plus 1 is just going to be 4 there. Okay, so we have what? We have we have found the value of A and the value of Q. That means we can now represent the equation of our exponential function. So remember now, our exponential function, no, quadratic function I mean, is given as f at x equals to ax squared plus q. So we can substitute the value of a. The value of a, we got it as -1, so this is going to be -x squared. The value of q, we just got it as a +4 there. So this will be what? This will be the equation of what? Of our quadratic function. Okay, so we can move on to the next question. So the next question that we have here, they say that determine the length of CD. Okay, so remember now, like I said, we already have what? We already have the equation of a quadratic. So that means on the equation of the quadratic here, we can see now this value of what? Of Q here, it will represent the value of D, because now the value of Q, it represents the y-intercept and is also the turning point. So if I can write now the coordinate of C here, I will say C is going to have the coordinate of what? Because now the value of what? Of Q is 4. So C is what? Is the y-intercept. So it's going to be 0:4. So that means already I get what? The coordinates of C. Remember, you must know how to analyze your functions. And then if you get the equation there, that means the value of Q there will be the value of C. So the question that comes, it says now, we must determine the length of CD. So if we look at this here, CD here is actually a vertical line. So if you determine the length of a vertical line, you always say now the length of a vertical line, for example, CD is going to be the value of y at the top minus the value of y at the bottom. So that is how you find the length of a vertical line. And then already we have what? The value of y here and the value of y there. So we can just minus those values and then we get the length of C. So we're going to say now the length of CD is equals to what? Y top minus y bottom. So the y top is the point of what? The one at the top is C. So that means we're going to put now the value of y for point C is going to be 4 there. And then we say minus, what is the value of y at D? So the value of y at D is going to be -3. So this is going to be -3 here. And then we find the length of CD to be what? 4 plus 3 is going to give us 7 units. Okay. And then now the question says that we must do what? We must determine the equation of the straight line that is passing through point A and D. Okay, so let me just clean up the mess here so that we can look at what is happening here. Okay, so they're saying now we must determine the equation of what? The equation of a straight line that is passing through what? Through point what? Let me clean nicely. That is passing through point A and D. So the line, straight line is going to pass between these 2 points, point A and point D. So now remember now, if you determine the equation of a straight line, you must know how to find a standard equation of a straight line. And then the standard equation of a straight line is always given as what? We are looking for 5.3.2. If you are looking for the equation of a straight line, is given as what? As y equals to mx plus c. So that is the standard equation for a straight line. But now, this straight line of ours is going to be a straight line that is going to pass through the point of A and the point of D. And then we already have the coordinates of A and the coordinates of D. That means now we can determine what? The equation of this straight line. But how are we going to do that? Remember, we must first find what we call the gradient. But how do we find the gradient? The gradient is found by saying what? Y2 minus y1 all over x2 minus x1. So in this case here, you can just choose now to say this is going to be my x1, and this is going to be my y1, this is going to be my x2, this is going to be my y2. So you're going to substitute the values of y and the values of x so that you can get the gradient. So you're going to say now, the value of y2 is going to be -3 here. So you're going to put -3 minus the value of x1 is going to be 0, y1 is going to be 0 there. And then the value of x2 is going to be 0 here. And the value of x1 is going to be minus 2 there. Okay, so we'll see now the gradient that we get is going to be how much? It's going to be a -3/2. So you can just put all that in your calculator so that you get the correct answer. So we have what? We have -3/2. That is the gradient. But remember, we are looking for the equation of what? Of the line that is passing through A and D. So after finding the gradient, we have to find out the value of C. And then how do we find the value of C? That means we just take the gradient and substitute it on our equation. So it's going to be -3/2x plus C. And then after we do that, we can select any point that is on the graph. Remember, we have point A and we have point D. So we can just choose point A or point D, and then we substitute them so that we get the value of what? The value of C. So in this case, I'm going to select a point D here. Remember, point D is having the coordinate 0 is to -3. So that means now the value of y is going to be how much? It's going to be -3 here. And the value of x is how much? The value of x is going to be 0. So I just put 0 there, and then I have plus c. So this will mean now the value of c is going to be what? It's going to give me -3 because this will just be 0 there. Okay, so I have what? I have my gradient and I also have the value of c. That means now on my general equation here, I can just substitute my gradient and the value of c so that I can get the equation of the straight line which is passing through point A and D. So you're going to say we found the gradient to be -3/2, and then we have x, and then the value of c is just a -3 there. So this will be the equation of the straight line that is passing through point A and D. Okay, so also we have these last two questions here, and then on these last two questions I would like to clean up all these things that we have here, so we can just clean it up so that we get a better understanding of what is happening here. So the question says now, for which values of x is the f at x greater than 0? So that means now they're asking us for which values of x is the function of f. Remember, the function of f is a quadratic function, is positive. And then remember, the function, it is represented by the values of y. So where is f at x positive? So remember, for all the values of y that are below the x-axis, we're going to have -1. For example, we're going to have negative values moving down like that. But now, for all the values of y, on top of the x-axis, they are all going to be positive. So on top of the x-axis, we are having what? The positive functions. So we're going to look at where the graph of f is positive. So the graph of f is going to be positive on top of what? Of the x-axis. And then this is where we have our graph here, from here moving up to there. Okay, but remember now we already have now the value of x here is -2, and the value of x there is 2. So for which values of x is that graph of f positive? So it's going to be what? From -2 up to 2. From -2 up to 2 here, we have the graph to be on top of the x-axis. That is what all that means. So we're going to say now 5.4.1. So our graph is positive in between what? In between what? Where x is -2 or where x is also 2. So in between what? In between -2 and 2. Or we can also represent this to say now x is an element in between -2 and 2. So you can just write it however way you want to write it. But now you need to know how to analyze that. Okay? So the last question here on this problem, they say now 5.4.2, determine the values of x for which the graph of f is a decreasing function. Okay, so remember now, if we have the graph of f here, which is our quadratic function, the graph is an increasing function. If we move from left to right, it goes up, is an increasing function. But if we move from left to right and then it goes down, that means it's going to be a decreasing function. So if we look at the graph of f here, from here, we start from left, going up as we go to the right. So that means from that point where we started up to the point of C here, this graph is an increasing function. But now, if we look at the point C here, as we move from this point to the right, what is happening is that our graph is going down. So that means now the graph is a decreasing function from the point of C and moving to the right like that. So, but now remember now at this point of C here, it is the origin whereby we have the value of x to be 0 there. So, but now for all the values of x moving on like that, we're going to have the function of f as a decreasing function because it decreases from that point moving on like that. So you're going to say now the graph of f is what? Is a decreasing function from all the values of x that are greater than 0. Or you can just say now x is an element from 0 to what? To positive infinity. So that is how you can represent that. So on the next question here, we are having question number 6. And then question number 6 here, remember before you start with the question, you must read the statement attentively. They say now the function of p of x is given as k to the power of x plus q, and then is described by the following properties. But now looking at what we have here, this function of p here is going to be an exponential function, and then we already explained now what is the value of q. The value of q is the asymptote, and then now the value of k in this case will just be the value of b. Okay. So we already know that because this is an exponential function. And then they also say now the value of k, it must be greater than 0, and the value of k it cannot be 1. So now the value of k must be greater than 0, but it cannot be 1. So that is what we know. And then they also say now the x-intercept is what? It has the x-intercept at what? At whereby we have x as 2 and y as 0. And then also the horizontal asymptote is given as -9. So we can just try, for example, to plot these functions that they give us here. We know this is an exponential function, but now they're telling us this exponential function, it is having the asymptote whereby the value of y is -9. So that means now at this point here, if it's -9, that means our function is not going to touch this point here at -9. That is our asymptote. So that means the value of q, we can just conclude to say that is going to be -9. And then they also tell us now we are having what? An x-intercept at this point here, which is going to be 2 here. So that point is going to be 2 is to 0. That is the x-intercept. And then now, if we want to plot our graph here, we need to find what is the value of k first, because we don't know if this graph is an increasing function or a decreasing function, because they said now k is greater than 0. But now if k is greater than 0, k can also be in between 1 and 0, and k can also be greater than 1. Because if this is the statement, k is in between 0 and 1, we know that is going to be a decreasing function. So our function is going to move like this, if that was the case. But now, if the value of k is bigger than 1, that means our graph is going to be an increasing function. So that means it's going to move like this. It's going to increase, and then it's going to touch the x-intercept that is given to us. Okay. So this is for what? For the value of k greater than 1. And then this will be for the value of k if it's in between 1 and 0. Okay. So you need to know how to interpret that and analyze that. But if you don't know how to do that, you can always refer to the previous videos that I have done on this kind of functions here. So now, the question that follows here is 6.1.1. They say now, write down the range of p. So remember now, we have to write down the range of p. We can clearly see now, p is on top of what? It's going to be on top of our function because the value of a is positive. It's going to be on top of our asymptote. So if it's on top of our asymptote, the range is just going to be what? A y is greater than the value of the asymptote, which is just -9 here. And you can also represent to say y is an element from -9 to positive infinity. Okay. And then they also say determine the equation of p. So, but now how do we determine the equation of p? So remember now p is given as what? P at x is given as k to the power of x plus q. And then already they gave us the asymptote. So that means the asymptote is the value of q. So we can just substitute our asymptote here. We're going to say p at x is equals to k to the power of x. Our asymptote is -9. So also, if we look at what? If we look at this, what information that we have, they also gave us what? The x-intercept. So now we have 1 point now. So we can substitute the coordinate of this point here, where x is 2, y is 0, and then we can get the value of what? The value of k. So now if we substitute this x-intercept here, we'll say now the value of y is 0, and then now the value of x is 2, and then we can solve for what? For the value of k, and then we have the equation of our function. So we're just going to transpose this 9 to the other side. So that means this is going to be plus 9 here. And then we have k squared. We can introduce a square root on both sides. This is going to be plus or minus there. So you're going to get the value of k to be what? To be either plus or minus 3. But remember, they told us the value of k must be greater than 0. So that means it must be positive. So we'll just therefore conclude the value of k is going to be 3. Okay, so if we get the value of k to be 3, that means our graph, it has to be an increasing function because the value of k is greater than 1. So if I can go up here, that means the solution is not going to be this graph of the red color here, because this is for a decreasing function. That means the graph that we have is going to be a graph that is looking like that, which is an increasing function because the value of k is greater than 1. So the last question says that sketch the graph of P and show clearly what? The intercept of what? Of the axis and the asymptote. So already now we have plotted this function here, 6.1.3. We have shown now the x-intercept. We have shown now the asymptote here. So we can just also find what? Our y-intercept, and then we can also show that coordinate there. Okay, so now how do we find our y-intercept? Remember, the equation now is given as what? P at x is given as 3 to the power of x, and then we have our q as -9. So if we're looking for that y-intercept here, we're just going to let the value of x to be 0. So remember, for y-int, you always make the values of x to be equals to 0. So you're going to say now p at 0 equals to what? Where we see x, we just put 0 there, and then we have -9. So remember now, this answer here, p at 0 is not going to be equals to -9, because now any number raised to the power of 0 is not going to be 0. It is always equals to 1. So you're going to have 1 minus 9 there. So that means now our y-intercept is going to be where we have -8. So now this point here, this point that we have here is going to be a -8. So you can also just calculate the y-intercept so that you can clearly show now your x-axis and also your asymptote. That means we have shown all that. Okay. So the next question that follows here is question number 6.2. So on 6.2 here, they say now, sketched below shows the graph of f at x. If you look at the graph of f at x here, it is k over x plus w. And then also the graph of g here, it is minus x minus 1. So the graph of f here, it has to be a hyperbolic function because the value of x is on the denominator. And then this graph of g here, we can just clearly see this is going to be a straight line. So they say now the graph of g is an axis of symmetry of f. So that means now this equation of straight line here is the axis of symmetry of our hyperbolic function, which is the graph of f. Okay, so in the previous video, I've already explained now, if you have what? The equation of symmetry of what? Of our hyperbolic function. That means now, in this case, we have the negative equation of symmetry, which is g of x equals to -x minus 1. So the value of c here on our what? On our equation of axis of symmetry, it is going to be the asymptote of what? Of our hyperbolic function. So automatically from that statement there that is given to us, we can just conclude to say now our hyperbolic function is given as f at x equals to k over x plus w. So this equation is what? Is the axis of symmetry of this function, which is hyperbolic. Therefore, the value of c here is going to be the same as the value of w, because that is what we call the asymptote of what? Of our hyperbolic function. Okay, so that means now we can conclude to say now, therefore, the value of w is going to be -1 before we can even go anywhere. Okay, so they say now the graph of f and g intersect at p and q. So that means now at this point of p and at point of q, we have now the graph intersecting. So they cross each other at point p and also at point q. So 6.2.1, they say now write down the value of w. So now remember, they told us this is the equation of axis of symmetry of this one. So that means now the value of c, it is the asymptote of this part here, which is going to be the w. So we can just say the value of w is just going to be -1. Okay, and then now 6.2.2, they say now the point what? -2 is to 7 lies on the graph of f, which is the graph of our hyperbolic function. And then we have to now calculate the value of k. So remember now, we have now our function to be f at x equals to k over x. And then we know the value of w is just -1. And then they gave us the coordinate. They gave us the coordinate of 1 point, which is what? -2 is to 7. So we can substitute this coordinate of the point, and then we can find the value of k. So where we see y, we're just going to put the value of 7 here. So that means it's going to be 7 equals to, because this is our y here. And then we have k over, the value of x is -2. So we're going to put -2, we have -1. So if we take 1 to the other side, this is going to be 7 plus 1. And then we have k over -2. And then 7 plus 1 is going to be 8 here. And then we have k over -2. So if we cross multiply here, that means k will multiply with 1. 8 will multiply with -2. We'll therefore find the value of k to be equals to -16. Okay, so if we have the value of k as -16, we can write our equation to say now, our equation of f at x, is actually given as what? The value of k is -16. And then over x, but now remember the value of w, it was calculated to be -1. So now they say we must find what? We must find the coordinates of p and q, the x coordinates of p and q. So but now remember the point of p and q are the what? Are the point whereby both the equations intersect. So now if the equations intersect, for you to find the coordinates of that intersection, that means you're going to equate the function. So you're going to say now f at x equals to g at x. Okay, so now where they meet, where they intersect, you always equate the equations, or you equate the functions, and then you get the x, a coordinate of that. So in this case, the function of f is given as -16 over x minus 1, and then the graph of g is given as what? -x minus 1. So if we solve this out, we can just transpose now this -1 to the other side. So this is going to be -16 over x. And then we have -x minus 1 plus 1, which will make this thing to be 0 here. Okay, so that means we are left with what? -16 over x equals to -x here. But now we can just multiply everything out by x. So, or we can just cross multiply here. We can say, okay, we can just cross multiply this. X will multiply with that one at the top, and that one will multiply with that. So -16 multiplied by 1 is just going to be -16. And then x multiplied by -x is going to be -x squared. So we can divide both sides by -1. And therefore we have 16 equals to x squared. So for us to find the values of x, that means we must put the square root on both sides. And then if you put the square root, it must be plus or minus. So this will mean now the value of x is going to be what? Is going to be a -4, or the value of x is going to be +4. But now remember, we are looking for the coordinates of p and q. So we can clearly see now the coordinate of p here is going to be what? Is going to be at -4, because it's on the left side of the equation. And then the equation, the coordinate for p here is going to be what? Is going to be +4. So that means now the x coordinate of what? Of the value of p here is going to be -4. And then the x coordinate of what? Of the value of q here is going to be 4. It's because now the question only said we must determine the x coordinate. They did not talk anything about the y coordinate. Okay, so remember, if you wanted to find the y coordinate, you can use any equation, because they are intersecting, and then you just substitute the value of x that you find, and then you find the corresponding y value. So now the last question that we have, They say we must write down the values of x for which we have minus 16 over x greater than negative x. So that means now we have negative 16 over x greater than negative x. So if we have something like this, that means now we can do what? We can just solve it, or we can analyze it, okay? So the best way it is just for us to solve this kind of a problem, okay? So how do we solve this problem? We're just gonna say, okay, we can cross multiply here because this is over 1. When we cross multiply, we're gonna get what? Negative 16 multiplied by 1, which is going to give us negative 16. And then we have what? X multiplied by negative x, which will give us negative x squared. Okay. But now, if you divide both sides by negative 1, that means now this sign is going to change. So if the sign changes, we're going to have what? A positive 16 being less than x squared. Okay, so now when you get the values of x, you're just going to do what? You're going to apply the square root on both sides. Remember, if you apply the square root, it's always going to be plus or minus. But now you see now the values of x are going to be greater than that value there, which is 4. Okay, so let's say, for example, the value of x is going to be greater. The sign is what? Is bigger on the x side. So it's going to be the greater than negative 4, or the value of x is going to be greater than 4. Okay, so that is how you would find those values of x for which that is the case. So that means for where the equations are, the equation of g, let me just also try to give you the analysis of this. So remember now, we get this thing here, whereby we have this thing as the equation of what? Of f at x, and then this one as the equation of g at x, because that is what happened when we simplified that here. You remember when we move the value of negative 1 to the other side, these things cancelled here, and then we just have negative 16 over x equals to negative x. So this will mean now we are having a question that is saying you have f at x being greater than g at x. Okay, so if you want to do an analysis of this problem like this, you're gonna look at what? Where the graph of f is on top of what? Of the graph of g. But now where is that? Okay, so looking at this point here, remember this is the value of x here. Okay, so you see now the value of f here is on top of the value of the graph of the straight line, which is this straight line here. So where the graph is on top, where the graph of f is on top of the graph of g, that means we're going to look at that values. What are those values? It's from what? It's from negative 4 up to what? Up to the x-axis, but it does not touch the x-axis there. So you can just say now, whereby we have the value of x being greater than negative 4, but now the value of what? The value of where x is 0 is not included, because that is the asymptote. Okay, so also you can just say where x is 0 is not included. But also you can also look at this part here. So between now our function, do you see now this is a straight line? So the straight line is at the bottom where? It's at the bottom here, because now the graph is on top here. So the graph is on top where? Is on top where the values of x are greater than what? Where they are greater than 4, because now that is the point there is 4 there. So you can say now the values of x are greater than 4. So that is how you would solve the equation. Okay, so this one here, this one of this part here is not going to be like this. We're just going to say it's going to be in between negative 4 and 0 here, because this part here is not included. If we just say greater than negative 4, we include everything. Okay, so that means now on our solution here, we have to say now the value of x for this first part here is going to be in between what? Where x is negative 4 and where x is 0. So that is going to be the solution there. And then for the other part of the equation, it's just going to be greater than 4 like that. Okay, so that is how you would solve all these 4 equations. Thank you very much.